Alrighty, I wanted to run through the lesson for 2.12 and explain what we did in class for anybody who wasn't here or just wants to have another look at it. So the start thinking part says Tyrone has dimes and nickels in his pocket. He has a total of $1. The first thing that I was looking for you to do is write an equation that represents this situation, assuming that x is the number of nickels and y is the number of dimes. I know usually we would say D equals the number of dimes and N equals the number of nickels, but since I know we are going to be graphing, I wanted to use X's and Y's. Now the students in class came up with equations and we discussed whether they worked or not. I had one student who had the equation of X plus Y equals 1, and I had to explain to them that that meant the number of nickels plus the number of dimes equals 1 altogether. This was one of the equations that the students came up with, which was 5x plus 10y equals 100, and that was a super useful equation. That is basically saying if you take the number of nickels and multiply by 5, you will find out how much money you have from nickels. If you have 10 and you multiply by the number of dimes, then that will tell you how many pennies you have for the dimes. And when you put the nickels and the dimes together, you end up having 100 pennies. Now another student had 0.05x plus 0.1y equals 1, and that was just talking about the equation in dollars and not in pennies. I like doing it in pennies, so then you're not dealing with decimals, but they are equivalent. It's just much easier to graph this. Part B says convert the equation to slope-intercept form and then graph the function on the graph to the right. So we were able to get it in slope-intercept form by subtracting the 5x and subtracting 5x and then dividing both sides by 10. You end up getting the equation y equals negative 1/2 x plus 10. Now, could you have graphed using x and y intercepts, substituting in 0 for x to get your y-intercept and substituting in 0 for y to get your x-intercept? Absolutely. But as you can see in my graph, I follow the points as I am graphing. I use my slope to follow points and put multiple points. When you graph using x and y intercepts, you really only end up with 2 points. And unless you're super neat or you're using Desmos, a lot of the points in between are probably going to be a little wonky. So anyways, we got the equation of y equals negative 1/2 x plus 10. I said graph it. So we went up to 10, which you can see on the graph, and I went down by 1 over by 2 and put a point. That wasn't enough though. I wanted to keep doing that as many times as I possibly could. So I went down by 1 over by 2, 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 and I just kept doing it. That was the first line that I graphed. It says give two possible combinations of nickels and dimes that will end up with $1. Now you can either just pick numbers and try them in your equation, or do how many just nickels or how many just dimes, or you could look at your graph and any point on your line is going to be a solution. So I just did just nickels or just dimes, and I got 0, 10, and 20, 0. So those would be two of the options where you would end up with $1. There's many, 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 many more options of combinations of nickels and dimes that end up with $1. The next one says, according to the graph, is 4 dimes and 5 nickels a possible combination? Well, be careful with this. Nickels is down below, even though I said dimes first, 4 dimes. So we would be looking at the point 5, 4. And when I look at 5, 4, 1, 2, 3, 4, 4 is now, I actually, if you look at my graph, I plotted the point 4, 5. Oops, ignore that. That is not the actual point. It's supposed to be 5, 4. So, but either way, 5, 4 is not going to, I don't know if you can see my cursor, but 5, 4, that point is not going to be on the line, so it is not going to be a solution. So that was it. Then we went to the next part. They said we had that first constraint was just that you had $1. The second constraint is that you only have 13 coins. So when we're looking at this, 13 coins, the way that we could represent this is just x plus y equals 13. Number of nickels plus number of dimes equals 13. Now, once again, it says convert this into slope-intercept form, and all we had to do is subtract x from both sides, and you end up with y equals negative x or negative 1x plus 13. That is a slope of negative 1 and a y-intercept of 13. It wants you to graph this. So we went back to our graph, and we went up to 13, plotted our point, and then we went down by 1 over by 1, put a point. And I just kept doing that until I found the intersection. So down by 1 over 1, down by 1 over 1, down by 1 over 1, down by. Once I found my intersection, I didn't keep doing it. And we'll explain why in just a second, why the intersection is important. Next, it said give 2 possible solutions. And when you're looking at that line, I found that 10, 3 was on my graph and 5, 8 was on my graph. And what that is a combination of dimes and nickels that add to be 13. So once again, now there are 2 constraints. The first constraint is that you have to have only $1. The second constraint is that you have to have 13 coins. Well, there are many, 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 many combinations that get you $1 and many, many, many combinations that get you 13 coins. There is only one case where you will end up with 13 coins and also end up with $1. Now, part 3 here says, fill in the blank with the following. It says if a point is on the line, then it is what? It is a solution to its equation, meaning if you put that point into the equation, it is going to make the equation true. If the point is not on the line, then it is not going to be a solution. So using this logic and looking at this graph, we know any point on one line is going to be a solution to its equation. Any point on the other line will be a solution to its equation. What is going to be the point that is going to be a solution to both? It is going to be that intersection. The intersection is going to be on both lines, therefore it is going to be a solution to both of them. While there are many combinations that get you 13 coins and many combinations that get you $1, the only combination that gets you both $1 and 13 coins is that intersection, which we see is 6, 7. That is 6 nickels and 7 dimes will add up to be $1 and also add up to be exactly 13 coins. So the concept here is when you are solving by graphing, you will just graph one line, graph the other line, and the intersection is your solution. We're going to do it both by hand and with Desmos. If you're doing it by hand, get it in slope-intercept form because that'll allow you to follow your points. Use your slope to find one point and then just keep going to find the other points. Now, this next problem right here is more complicated. It says you are buying items from the bulk section at Sprouts. You're purchasing almonds, and chocolate chips. Almonds are $9.50 a pound and chocolate chips are $5.75 a pound. You need to buy 5.5 pounds combined and you ended up spending $44.75, not thinking about tax. So we need to have 2 equations. And the way I explain this is the best way to do this is figure out what totals they're talking about. So in this case, the 2 totals that they're talking about is total pounds and total money. So we went in class and wrote 2 equations. The total pounds is X pounds of almonds plus Y pounds of chocolate equals 5.5 pounds. For the amount you spent, it's $9.5 times the number of pounds of almonds plus $5.75 times the number of pounds of chocolate equals $44.75. We then took out our cell phones and our computers and we went and Googled Desmos, D-E-S-M-O-S, and we clicked on the part that says graphing calculator. You don't even have to get these into slope-intercept form, which is nice for Desmos. We put in those equations. I know I put it in slope-intercept form, but you didn't have to. You could have just left it as is. When you graph them, the graph looks kind of like the one that I have on the side here, and you found your intersection to be at 3.5, 2. And the meaning there is that is 3.5 pounds of almonds and 2 pounds of chocolate chips. Well, there are many combinations that would get you 5.5 pounds and many combinations that would get you $44.75. There's only one combination that will get you both of those, and that is 3.5 pounds of almonds, 2 pounds of chocolate chips. The next one says you are trying to make a keto snack that consists of only fat and protein. You want to have 172 calories and 33 grams. I forgot in this problem to remind you guys that it is 4 calories per gram of protein and 9 calories for a gram of fat. So we had to write 2 equations again. We think about totals. The 2 totals are total calories and total grams. Your equation for total grams is X grams of protein and Y grams of fat is going to get you 33 grams total. And the next one is total calories, 4 calories per gram of protein, 9 calories per gram of fat is going to give you the whole 172 calories. Once again, we stuck that in Desmos. You do not have to get it into slope-intercept form. When you stick it into Desmos, well, there are many combinations that would get you 172 calories and many combinations that would get you 33 grams. There is only one combination that will get you both of those, and that is 25,8. That would be there are 25 grams of protein and 4 grams of fat. Okay. The conclusion is basically to solve by graphing, you just have to graph both of your equations, find your intersection, and your intersection is your solution. In class, we talked about if you do not have intersection because they are parallel, there would be no solution. And if the lines are on top of one another, then it would be infinitely many solutions because there's infinitely many intersections. This is true because a point on the graph is a solution to the equation. If the point is on both graphs, then it is a solution of both. Now, when we look at our homeworks here, the first one is asking for what set of equations would be representing the situation. Once again, one equation would be the total scarves or total, hang on, knitting club, so 24 scarves and hats. So the total scarves and hats together, and the other equation has to be the amount of money you made. So S plus H, number of scarves plus hats, come together to be 40. And it's $18 for a scarf and $14 for a hat, and you make $700 together. So that C would be the correct one. On number 2, there are 2 different ways to figure out if the point is a solution to one, both, or neither of the equations. You can either just substitute it in, which is what I did here, and just saw if it makes one equation true, both equations, or neither. Or in class, I was explaining to students, you could pop both of them into Desmos and just see if the point 3, 4, 4, 2.5, see if those points are on one of the lines, both of the lines, or neither of the lines. The next one says, is it possible to have more than one pair that is a solution to both? Well, kind of not. The answer I said was no, because 2 lines can't intersect more than once unless they're the same line, and then it would be infinitely many solutions. On number 3, here is your situation. I already wrote out your equations and graphed it, and I just said what is going to be the combination of quarters and dimes that have that amount of coins and that amount of money, and we end up finding out that it is 8 and 11. 8 quarters, 11 dimes. Number 4, y is the equation 25x plus 10y equals 2.85, not representing the situation above. Well, the whole left side is talking about pennies and the right side is talking about dollars, and you cannot mix those. It is basically, if you go and you think that that's all pennies, it's saying that you have 2.85 pennies. Or that's saying it's $25 per quarter, which just makes no sense. On this one right here, you were supposed to graph. And when you go over and graph this, it says you can use Desmos if you make your 2 equations. Well, first off, take a look at the answers for A and B. We've got, it says that 3 times the first number plus 2 times the next number is 34. It says give any example of numbers that would make this true. Then write an equation and graph it. Then it also gives me another one that says that half of the first number and twice the second number, when you add them together, gets you 14. I said you could use Desmos, so I went over and put those into Desmos, and I found out the intersection was 8 and 5, meaning the first number is 8 and the second number is 5. Please remember, this is not for you to write down my answers. This is for you to check your answers after you've done it on your own. The next problem, you are supposed to be graphing by hand, no Desmos, unless you're just checking your answer with Desmos. So you're supposed to have a y-intercept of -3, go up 2 over 1, up 2 over 1, up 2 over 1, and then the other one would have a y-intercept of 6, down 1 over 4, and you find your intersection is at 4, 5. That means 4, 5 is the only pair of numbers that would make both of your equations true. The next one, I graphed the first one having a y-intercept of 5, down 2 over 3, down 2 over 3, and kept doing that. And then the next one, when I got it into slope-intercept form, was y equals -1x plus 7. So I started at 7, went down 1 over 1, down 1 over 1, and I found my intersection, and it was at 6, 1. 6, 1 is the only point that would make both of your equations true. This last problem that you guys were looking at, it gives different information, whether the person is starting at the start line or if they're starting away and how fast they're going, and you're supposed to match up the equations. This basically incorporates your understanding of y-intercepts, and slopes. One of the kids started not at the start line, but 4 miles away from the start line. So we knew that the person who did not start at the start line was A. And that is why we knew the youngest sibling was graph A. Then the other one says that one person is going faster than the other. The person that is going faster is going to be B, and the person that's going slower is C, because the slopes, the miles over hours, the speed is going to be different. All right, thank you for watching that. Once again, please do not just be writing down my answer. This is a way for you guys to get instant feedback on how you're doing, not to go over and get out of having to do homework. Thanks for watching.